कंगना 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 क्या बात है।
Hello everyone, this question came in CSIR Net Chemical Sciences December 2018 and this question is based on the lattimer diagram. I have already made a dedicated video, but in this question one more formula which will be used, which I will talk about in the later part of the video. And sorry for the pre-written because I recorded, but due to the storage issue the file got corrupted. But anyways, I let me go through you about the question. So in the question we have been given this equation, fine, and the temperature has been given, the reduction potential has been given for this SN4 positive as well as for SN2 positive. Now the examiner is asking about what will be the equilibrium constant for this given reaction. So first of all, what we will do, that whatever the data has been given, write same as it is. So this is SN4 positive plus 2 electron, it it give rise to SN2 positive. So the reduction potential has been given 0.15. We have taken it as equation 1. Now this SN2 positive, the reduction potential of SN2 positive when goes to Sn has been given as minus 0.15. So if you look at these two equations carefully, if I let me give it a equation 2, this one, fine. So if you look at this equation, if I just reverse it and add both the equation, we will get this same equation which has been given in the question. So what I did is I reversed equation 2, this equation. So I am getting this Sn here, then Sn2 positive plus 2 electron. Alright, if I am reversing this equation, that means the reduction potential will also get reversed. So from negative it will become positive. Alright, so this is the equation. Sn changes to Sn2 positive plus 2 electron. Now the potential is positive. So what I did is just add these two equations, equation 1 and equation 3. So we will get this equation, Sn4 positive plus Sn, and this is 2 electrons cancels by this 2 electrons, left hand side cancels by right hand side, fine, and this is Sn2 positive and this is also Sn2 positive. So when you will add both of them, it will become 2Sn2 positive. Now the thing is, if you write the delta G we all know that formula of delta G equals to minus NFE, where F is Faraday constant and N is the number of electrons involved in the reaction. So this will become minus NFE for this reaction. So if we are taking this, since the electrode potential can be added, so we will take this electrode potential from the equation 1. So it will become minus NFE. So this minus, for N is the number of electrons involved. So in this equation number of electrons is 2 because it is going from 4 positive to 2 positive. So this is minus 2 into 0.15, fine, and this is F, Faraday constant, plus this equation third also got added. So this is again how many electron change, as you can see there is 2 electron change. So right, this is plus minus, N is 2 and F as it is, and E is how much, this is 0.15. Are you getting my point? So just add them. So this is minus and plus minus become minus, and take this F const outside. So it will become 15 to the 30 and this is also become 30. So this is nothing but your 0.60. Alright. So this minus cancels out by this minus and this F cancel about, and we are left with E naught equals to, this is 0.60 upon 2 equals to 0.30. This is the potential we have got. Now, but in the question, if you look at the equilibrium constant has been asked. So there is a direct formula which is given by K equilibrium equals to 10 raised to power N E naught cell divided by 0.0591. Fine. I'm not going to talk about the derivation of this equation because it will itself take 10 minutes. So it will become, this is how much, this is 10 raised to power n is number of electrons involved. So how many electrons are involved in this reaction? 2 electrons. So right here 2 into E naught we have already calculated, which is your 0.3. So write 0.3 divided by, this is how much, 0.0591. so it will become 10 raised to power, this is around 3 to the 6, 0.6 divided by, and this is 0.059, so we can write it as around 0.06. Fine, so it will come around 10 raised to power 10 point something, which is accurate is 0.8. if we take this value, this is 10 times, so this is 10.08. and if you look at in the option, so which is the, I think I haven't written the option, so the answer is this is 10.08. you can check the options from the question paper itself. So for the next time, thank you, and please subscribe to my channel, and bye.